Good morning, everyone. Welcome to Chemistry with Professor John. All right, let's finish up alkynes. Okay, and this is where we left off last time. Okay, now water react with water in the presence of acid and mercury sulfate. Okay, so this should be Markovnikov additions, meaning OH to the more substituted carbon, because that's a more stable cation. So remember that. Okay. Now, in this case, we got 1, 2, 3, 4. If you go from left to right, 1, 2, 3, 4. You go from right to left or left to right. It's the same. So it doesn't matter. It doesn't matter which one. Okay. So you go. I'm just gonna do line formula 1, 2, 3, 4, 5, 6, 7, 8. So we got 8 carbon, right? So you have 1, 2, 3, 4 double bond OH. So you can see 5, 6, 7, 8. Okay, so that's gonna become 1, 2, 3, 4 double bond O. We're done. Okay, a ketone. Now this one it does matter. The second one, so that's done. The second one, we're gonna put in the OH right here. Okay, that's on that side there's more branches. Okay, so therefore it's gonna become okay, therefore there, done, right? So much quicker with the live angle formula. Okay, this one obviously the OH going there. That's a C. So that's gonna become 1, 2, 3, 4. Okay, that's double bond. So you guys see it? 1, 2, 3, 4, 5, 6, 7, 8. That's how I keep track of carbon. So number 4, we have OH, and then number 3, we have 2-methyl. 1, 2. 1, 2, 3, 4. Yep, we can do that. Okay. All right. Now, just want to compare. This is Markovnikov. So Markovnikov, so the OH added to the internal. So you got 2 different carbon. That's more substituted. That's less substituted. Okay. Now, when you do Markovnikov, that's where the more substituted carbon is where the OH comes in and turn into a ketone because it's inside. Now, if you do anti-Markovnikov, anti doesn't mean bad. It just means different. The OH gonna go to the outside carbon, and therefore it become And on the outside carbon, notice it's got the hydrogens. So it becomes double bond O, and that's making an aldehyde. Okay, so it depends on what we want. Every time you see BH3, that's a good indication of that is anti-Markovnikov. All right, because the borane will take the place outside, will be bonded to the last substituted carbon, and then subsequently replaced by the OH. Okay, the oxygens. Okay, so if we do this one, the OH will be right there, and the hydrogen will go to the inside carbon. So we would get a C. We actually, it's gonna get the HC double bond, CH, C, 3 methyl, which then turn into an aldehyde. Yep, because this carbon will wrap the hydrogen and then become double bond. Oh, so we got 1, 2, 1, 2, 3, 4, 1, 2, 3, 4. There. Okay. All right. Now, easy one. Hydrogenation, number 6. Adding hydrogens. If we don't stop, if we don't have anything special, like special catalyst to stop the addition, it will be added 2 hydrogen. I mean, that's 4 hydrogen atoms. Because both reactions are very spontaneous. Negative delta H. Okay, so it's gonna go all the way to alkane, unless we have something special. Okay, it doesn't matter how well we try to control, how hard we try to control the addition, the hydrogen will go, both of them will go right away. Okay, so you start with a triple bond, you become single bond. Okay. All right, now, unless we use something special like Lingala catalyst, that's palladium and quinoline. Lingala catalyst has quinoline and barium sulfate as well. Also has palladium, and then with that, it will stop. It will put the 2 hydrogen on the same side. Notice that make it a cis. Okay, and then we can keep it that way. Stop right there, or go on and reduce it all the way to alkane. Okay, now if we want to do a trans, okay, we have to use different reagents. That will be either sodium or lithium, both of them, either one will work, in ammonia. So the triple bond will take the hydrogens from ammonia. Okay, we'll have a chance to look at the other study guide, the complete study guide with the mechanisms on this one. Okay. All right. So we got 3 options. Just adding hydrogens with palladium. Okay, so in summary, if we have a triple bond, If we do just hydrogens and platinum or palladium, we got alkane. If we do hydrogen with Linla, uh, palladiums and everything, okay, we got the alkene with 2 hydrogen cis alkene. And this is regardless, you can get alkane regardless how little hydrogen you use, okay? If we do lithium or Na, not both, in the presence of ammonia, liquid ammonia is going to go 1 C double bond that's going to be a trans alkene. Okay, so that's a summary. So we can do whatever we want. That's really nice, right? Now, if you decide to do oxidative cleavage, oxidize it, okay? We got 2 carbon to oxidize. Well, this is a strong one, okay? Either one. Remember, this is a triple bond, so when you oxidize, you still have a double bond. You go from triple to double, and that's gonna show up in the oxygens. You got 2 carboxylic acid. Okay, regardless of what you use, KMNO4 or O3. When you have the double bond, you have if you remember, you have an alkene double bond. If you use ozone, they become either aldehyde ketone to cut the double bond. If you use KMNO4, then you got both carboxylic acid. But here it doesn't matter, ozone or KMNO4, they both turn into carboxylic acid. If you do terminal, obviously, you got carbon outside. There's only 1 carbon, so it's become CO2. That's CO2. That's the highest oxidation state, right? Okay, here's a really cool one. Alkynium ion. If you throw in a very strong base, it's going to wrap that hydrogen to form the alkynium, which is C triple bond minus acetylide ion. And that's an excellent nucleophile. A good nucleophile means SN2. And here we go. SN2 connect to carbon of halide, kick the halogen out. So we end up with a larger alkyne. It's more example here. So every time, but you have to have a terminal alkyne with CH. That's the only way we can make the connections to get start out with a smaller alkyne, end up with a longer alkyne with more carbons. And we want to do the primary, okay? It's the best. And then if we do tertiary, we'll get elimination products. Okay? Acetylene is really good because you can do it on both sides. You do one side at a time. Your terminal alkyne, and you got an internal alkyne. All right, so here we go, acetylene, and end up with bigger alkyne, And then we can also do acetylene again and get an alkyne, and then we can reduce the alkyne the way we want. Like Lindlar catalyst, just stop at alkene, and then we can do hydrolysis, either Markovnikov, or in this case it's anti-Markovnikov, to get the terminal low degree alcohol. In this case it's primary alcohol. We can also, these are all possible things we can do. We can do HBr, that's Markovnikov. So we got the Br into the more substituted carbon. We can just do Lindlar catalyst. After we got the alkyne, get the cis alkene, hexene here, and we're done, for example. Okay, so pretty good set of reactions. These are very practical, very popular. 8 different reactions, including synthesis of alkyne. Okay, and then in the next video we'll be looking at the complete study guide, the other one, when we look at more mechanisms and more example. All right, thank you guys, appreciate you watching. See you in the next video. Thank you again.